Let's try another one of these, and I'll tone down the silliness this time. Find the volume of the solid obtained by rotating about the x-axis, the region between y equals x and y equals x squared. Gosh, is that a mouthful. First step, I'm going to draw my region. That means drawing the graphs of the two different functions, y equals x and y equals x squared. Notice they did not give us bounds for this region, so we need to find whatever coordinates that these graphs cross each other. Now, this picture is skipping forward a step. Let's just focus on the positive x-axis for a moment. I know that my function y equals x is going to be a line with slope 1 running through the origin, and my function y equals x squared is going to be a parabola, again with vertex at the origin. So it must be that the function y equals x is on top, because squaring numbers close to 0 gives me a smaller number. The picture also spoils the intersection points. These functions have to agree when x equals 0, and also they have to agree when x equals 1, since 1 squared equals 1. Well, that's good. I want to find my typical shell. So again, I'm taking this blue wedge shape and I'm rotating it around on my y-axis. It comes back over here, but this picture, this diagram, is not in 3D. So the rest of this 3D shape has been omitted to make the picture easier to look at. They've drawn in a single one of the cylindrical shells above the coordinate x, and this one has been drawn in perspective. So imagine it bulging forward off of the computer screen, bulging backward behind your monitor. It's a 3D shape in our imagination. If I was going to use the method of shells, I'm taking a piece of the x-axis. I'm looking for the shell that this is generating when I rotate. So the height here, if the shell starts at x squared and goes all the way up to x, then my height is going to be x minus x squared. Okay? So my volume integral would look like this. Volume is equal to the integral from 0 to 1. And my integral formula says circumference times height times thickness. Circumference is always going to be 2 pi x. Thickness is always going to be dx. The height this time around is x minus x squared. The height is the only part of this formula that will be different depending on the function we're given. So as before, I can pull out that 2 times pi, and I have the integral of a fairly friendly looking polynomial. And after fundamental theorem of calculus, I don't see typos on this slide, fortunately, I get pi divided by 6.